The most distant human-made object is NASA's Voyager 1 spacecraft, which has managed to reach the vastness of interstellar space. Imagine launching a spacecraft 45 years ago and it's still venturing through regions no one ever imagined it would reach, well beyond its originally intended mission lifespan. That's the incredible reality of Voyager 1, a spacecraft that continues to redefine the limits of space exploration. What's even more astonishing is that this brave little spacecraft, now billions of miles from its launch point, still sends back valuable scientific data using technology older than a cassette player. That's not an exaggeration, it literally uses an onboard system from the 1970s. And now, decades after launch, Voyager 1 has made a discovery so significant it has shaken the global scientific community and captivated the imagination of people around the world. So what exactly did it find in the remote reaches of space, and what could it mean for life here on Earth? This story began with a key moment in the history of space exploration, when two of the most legendary space missions were born. It all started thanks to Gary Flandreau, a brilliant mind at NASA's Jet Propulsion Laboratory. Using just a pencil and engineering charts, Flandreau realized that during the late 1970s and early 1980s, the four gas giants, Jupiter, Saturn, Uranus, and Neptune, would align in a rare cosmic formation. This planetary configuration, occurring only once every 176 years, created a sort of celestial highway. If timed right, spacecraft could use the gravitational pull of each planet to slingshot from one to the next, drastically reducing travel time. This gravity-assisted technique, also known as a gravitational slingshot, meant that a spacecraft could reach Neptune in just 12 years, a journey that would normally take at least 30. Faced with this extraordinary opportunity, NASA acted swiftly. In the summer of 1977, just 15 days apart, two identical spacecraft, Voyager 1 and Voyager 2, were launched, each destined to take advantage of this once-in-a-lifetime planetary alignment. At the time, no one could have predicted that these twin spacecraft would go on to break nearly every record in the history of robotic exploration. Although their initial missions were only scheduled to last 4 years, both Voyagers far exceeded expectations. More than 45 years later, they continued to send data back from the outermost boundaries of the solar system. Voyager 1 and Voyager 2 became the farthest-traveling spacecraft in history, venturing farther into space than anyone could have imagined when they first left Earth. During the early part of their journeys, they provided us with breathtaking, never-before-seen images of the gas giants and their moons. Voyager 1 revealed dynamic volcanoes on Jupiter's moon Io, and Voyager 2 amazed scientists with ice geysers on Neptune's moon Triton. These encounters shattered previous beliefs about these frozen worlds and transformed our understanding of planetary systems. What we once thought were cold, dead rocks turned out to be active and mysterious places full of unexpected geological phenomena. Voyager 2 holds the distinction of being the only spacecraft to visit both Uranus, in 1986, and Neptune, in 1989. These historic flybys yielded spectacular findings, including the discovery of previously unknown moons, mysterious magnetic fields, and even giant storms in Neptune's atmosphere. Each spacecraft, roughly the size of a Volkswagen Beetle, was equipped with groundbreaking technology for its time. The journey began with gravity-assisted maneuvers around Venus and Jupiter, sending the probes further than any had gone before. They passed through the hazardous asteroid belt, a feat that had only been accomplished once by Pioneer 10 and 11, and then continued their journey toward the outer planets. Despite being equipped with less than 70 kilobytes of memory, far less than what a modern digital photo requires, the spacecraft had to perform highly complex tasks. Data collected by their scientific instruments was recorded on magnetic tape recorders and transmitted back to Earth using a 23-watt transmitter, roughly the power of a refrigerator light bulb. To send and receive messages across these astronomical distances, the Voyagers used 12-foot-wide satellite dishes and encoded their transmissions in radio waves. As the probes moved farther from Earth, traveling several light-seconds more every day, the challenges of communication became immense. Today, signals from Voyager 1 take more than 22 hours to reach Earth. And as the background noise from human-made sources like radios, phones, and satellites increases, Extracting these faint signals becomes ever more difficult. And yet, despite these limitations, the Voyager spacecraft continue to transmit vital data. They've given us a new perspective on the structure of the solar system, the nature of interstellar space, and the possible shape of the cosmos itself. Their journey into the unknown eventually led to what scientists had long anticipated: crossing into interstellar space. At the edge of our solar system lies a boundary known as the heliopause, where the Sun's influence ends and the domain of other stars begins. Scientists originally estimated the heliopause to lie at around 50 astronomical units from Earth. Incredibly, Voyager 1 reached this point and crossed it on August 25, 2012. Yet what happened at that moment defied expectations. The transition into interstellar space was predicted to come with a sudden increase in cosmic rays, high-energy particles born from distant supernovae and other violent cosmic events. And indeed, Voyager 1 did record a dramatic increase in plasma density, confirming that it had passed into a new region. But strangely, there was no corresponding change in the magnetic field direction, something that had been expected. Scientists were left baffled. It suggested that the interstellar magnetic field might not be as different from the solar field as we assumed, or perhaps, that the transition wasn't as simple as crossing an invisible wall. The heliosphere, which serves as the Sun's magnetic shield, had long protected the solar system from the brunt of interstellar radiation. Yet once Voyager 1 crossed this boundary, it entered a vast and mysterious sea of particles and magnetic forces, an environment unlike anything it had previously encountered. As the spacecraft continued its voyage through this unknown territory, it began to detect strange anomalies, fluctuations in the magnetic field and unexpected changes in plasma wave activity. These were subtle but persistent, almost like ripples on a calm surface disturbed by something unseen. Scientists were puzzled. Could this be evidence of interstellar turbulence? Or perhaps signs of structures or currents in the space between stars? Some of the most compelling data suggested that the interstellar medium, the tenuous material between star systems, was far more dynamic than previously imagined. These findings challenged long-held models and sparked new theories about how our solar system interacts with the galaxy. And the journey isn't over yet. Though it will take thousands of years for Voyager 1 to reach the distant Oort cloud, the hypothetical shell of icy objects that marks the farthest edge of the Sun's influence, its mission continues to expand human knowledge. Even now, as its power source slowly weakens and its systems begin to shut down one by one, Voyager 1 sends home faint messages, precious data packets traveling through the silence of space. The Voyager mission has become far more than a scientific endeavor. It is a symbol, a tribute to human curiosity and ingenuity. It reminds us that even with outdated technology and uncertain odds, humanity can reach beyond the stars. It tells us that our thirst for knowledge is stronger than time, and that our desire to explore is limitless. And now, with its latest discovery, Voyager 1 has reminded the world once again why space exploration matters, not just for the sake of science, but for the story of who we are. It has shown that exploration is not just about reaching new places. It's about understanding our place in the cosmos. Let us know what you think in the comments. And if you found this story as inspiring as we did, don't forget to like the video and subscribe to the channel for more discoveries from the final frontier.